The next question is, determine whether the signal x of n equal to 1 plus sine 5 pi n by 3 plus pi by 2 is periodic. Find the fundamental period if it is periodic. Okay, we have to check whether this signal is periodic. I can write the signal as x of n is equal to 1 plus sine 5 pi by 3 n plus pi by 2. Okay, and this 1 is added to sinusoidal signal, which means we are clamping the signal. EC students can clearly understand it. We are clamping the signal by 1 unit, which is not going to affect the periodicity of the signal. Okay, similarly, there's a pi by 2 addition inside this argument, which is a phase shift, which is also not going to affect the periodicity of the entire signal. That means the presence of 1 is a don't care and pi by 2 is also a don't care. Okay, so what we have to check is the omega, angular frequency of the signal, which is nothing but the coefficient of n, that is 5 pi by 3. Okay, therefore omega equal to 5 pi by 3. And how would you check the signal is periodic or not? You just divide omega by 2 pi, which will give you 5 pi by 3 by 2 pi, which is giving a ratio of integers. Is that right? It will give you 5 by 6 is a ratio of integers. Therefore, definitely x of n is periodic. Okay, so what is the period? You know, omega equal to 5 by 3. Therefore, the time period n equal to 2 pi by omega, which is equal to 2 pi by 5 pi by 3, which will give you 6 by 5. Many students at a single glance may tell that because time period for a discrete time signal this is not an integer value, this signal is not periodic. No, that is wrong. This is a sinusoidal signal and we got it as periodic. So what you missed is there is another provision, n equal to actually 2 pi by omega into r, and this r is the presence of any integer, right? Any integer multiplied by this n value that can make the total value an integer. Okay, let me explain. So this 6 by 5 can be multiplied by r equal to 5, so that the total answer is 6, which is an integer. Okay, so an r should be provided here, so into r, and that r given as 5 will give you 6. Okay, therefore n equal to 6 samples. So the signal is periodic with a period of 6 samples. Alright, next let us solve this problem. For the signal f of t, first sketch f of 3 minus 2t, then find the energy of the signal f of t. Okay, so in order to find or sketch f of 3 minus 2t, we can see that there are two operations in f of 3 minus 2t, both shifting and scaling. So as per precedence rule, we first find out shifting, then scaling. So from f of t, first you find out f of actually this f of 3 minus 2t, let me write here, this is actually equal to f of minus 2t plus 3. Okay, so to find out the signal from f of t, first you do f of t plus 3. Okay, then from f of t plus 3 you do f of minus 2t plus 3. Alright, so first we are finding f of t plus 3. That means f of t shifted by 3 units to the left. So the portion at minus 2 comes to minus 5, and it lasts 2 units. Okay, then this portion comes, then 1 unit here, and final portion is here. Okay, so the value at 1 is now at 1 minus 3, that is minus 2. That's right. Okay, the amplitudes are not changed, 2 and 1. That is f of t plus 3. Now we have to find out f of minus 2t plus 3. Okay, we are going to draw f of minus 2t plus 3. Here the scaling factor is minus 2, right? Scaling factor is minus 2. So we have to divide every time instant in f of t plus 3 by minus 2, and the corresponding amplitude goes to that portion. Okay, so initially minus 2, this amplitude goes to minus 2 divided by minus 2. Because the scaling factor is minus 2, I am dividing this instant by minus 2. So minus 2 divided by minus 2 gives 1. So this amplitude goes to plus 1 here. That's what I'm going to draw now. So that amplitude goes to plus 1, right? Now this this interruption is at minus 3. So we have to divide it by minus 2, because minus 2 is the scaling factor. So minus 3 by minus 2 gives plus 1.5. So this interruption is at plus 1.5. So there is some more here, 1.5. Okay, so that is at 1.5. Okay, now listen, the final point is at here, minus 5. So divide minus 5 divided by minus 2, which will give you 2.5. So the final portion is at 2.5. Some more here. Okay, 2.5. And the amplitudes are not changed because there is no amplitude operation. We have done only time operation. Okay, so there is answer to the question A. Fine. Now we will see the question B. Find the energy of the signal f of t. We have to find out the energy of this signal f of t. F of t is actually a composite signal. I can identify x1 of t as this triangular signal which has a duration from minus 2 to 0, and I can denote x2 of t as this rectangular or gate function from 0 to 1. Okay, so I can now barely say that energy of signal f of t is equal to minus 2 to 0 x1 of t the square plus integral 0 to 1 x2 of t the square dt. Okay, now the only hurdle left behind us is to find out an expression for x1 of t and x2 of t. There is no need to find out any expression for x2 of t because it is a constant value 1. So we have to find out the expression for x1 of t. Clearly x1 of t is a ramp function, or it is a straight line, right? It's a straight line. Do you know the expression for straight line? Any straight line is given by y is equal to mt plus c, where m is the slope and c is the intercept. Okay, now what is the slope of this line? What is the slope of this line? Slope is actually y-axis, delta y divided by delta x, which is equal to 2 minus 0 divided by 0 minus minus 2. I can write it as slope is equal to 2 minus 0 divided by 0 minus minus 2, which is equal to 2 by 2, 1. Slope is 1. Okay, and what is the intercept? Intercept is the distance between x-axis and the line. Okay, straight line between origin at x-axis and line, that is nothing but 2. So the intercept c equal to 2. So I can write the expression for the straight line as x1 of t is equal to m is 1, so 1 into t plus c is 2. So x1 of t is t plus 2. That's obvious because this is a ramp signal. If the signal was like this, then it is pakka ramp signal, x of t equal to t. But you can see the signal is shifted twice to the left, so it is t plus 2. This is t plus 2. Okay, anyway, I'm not going to consider this. Okay, so we have obtained x1 of t as a t plus 2, and x2 of t, I can barely steadily say it is 1. Okay, now we can find out energy is equal to minus 2 to 0 x1 of t the square, that is t plus 2 the square dt, plus integral x2 of t is from 0 to 1 1 square dt. Okay, so that comes to be integral minus 2 to 0 t square plus 4t plus 4 dt plus integral over 0 to 1 dt. Okay, now we can find it as integral t square is t cube by 3 plus 4 into t square by 2, which will give you 2t square plus 4t. Okay, this is within the limits minus 2 to 0 plus integral dt is t within the limits 0 to 1. Now we have to put the limits 0 plus 0 plus 0 minus of minus 2 cube by 3 is minus 8 by 3, minus 2 square into 2 is plus 8, 4 into minus 2 is minus 8. Okay, plus while we put the limits in this equation, you will get it as 1. Okay, so this can be written as plus 8 by 3 and this to cancel, plus 1, which will give you 11 by 3 joules. So this is the correct answer. Alright, okay, we will see the next question. Check whether the following systems are linear and stable. First question is y of t equal to e raised to x of t. So the procedure is, first we take the input as a weighted mixture of two signals, weighted a1 into x1 of t plus a2 into x2 of t. This is how you take a weighted mixture of two signals. Okay, now we will obtain the output. We name it as y1 of t using this input. So y1 of t equal to e raised to, the input is now the mixture. Okay, e raised to a1 x1 of t plus a2 x2 of t. You can rewrite it as e raised to a1 x1 of t into e raised to a2 x2 of t, and now further simplification is possible. Let this be equation number 1. Okay, now you take the output as a mixture. Okay, let y of t is equal to, y of t equal to a1 y1 of t plus a2 y2 of t. Okay, that implies y of t is equal to a1 into, what is y1 of t? Don't confuse that this y1 of t is not same as this y1 of t. Okay, this is a mixture. Okay, if y of t is equal to e raised to x of t, then I can write y1 of t as a special case as e raised to x1 of t. Similarly, y2 of t will be e raised to x2 of t. Okay, so instead of y1 of t, I can write this e raised to x1 of t plus a2 into, instead of y2 of t, I can write e raised to x2 of t. Now this is our output, mixed output. This is equation number 2. Equation number 1 was the output obtained when the input taken was mixed. In equation number 2 was the output itself as mixed. Okay, now equation number 1 is not equal to equation number 2, and that implies the system is not linear. Okay, and now we will check stability. How will you check stability? Stability is actually Bibov stability. Bibov stability says that if you take an input which is bounded input, then it should give bounded output also. Okay, that is bounded input should give a bounded output. Such systems are Bibov stable. Okay, so here y of t is equal to e to the power x of t. Assume that input is bounded. mod x of t is bounded. It is not infinite. Therefore, what is y of t? Then we can say that mod y of t is equal to mod of e raised to x of t, which is also a finite value, right? If x of t was unbounded, then e raised to x of t would give you an unbounded amplitude, right? Increasing exponential. But if x of t is bounded or converging, then e raised to x of t will also be converging, which implies the system is stable. System is bibostable. Okay, let's see question number B. We have to check first whether linear or not. Question is y of n is equal to x of n minus 1. Okay. As per the procedure, take x of n is equal to a mixer a1 x1 of n plus a2 x2 of n. Alright. Now what is x of n minus 1? The given input multiplication is x of y of n equal to x of n minus 1. So what is x of n minus 1? N minus 1 a1 x1 of n minus 1. This is a function. You wherever you find n, replace it by n minus 1. So a1 x1 of n minus 1 plus a2 x2 of n minus 1. Okay. So now let us write the output y dash of n, something y dash of n is equal to, from this equation, what is y dash of n? Y of n or y dash of n is equal to a1 x1 of n minus 1 plus a2 x2 of n minus 1. Okay, that must be our equation 1, right? Now we'll be taking a1 y1 of n plus a2 y2 of n. That is, the output itself is mixed. Okay, that will give you a1 into, what is y1 of n? If y of n is equal to x of n minus 1, then we can write y1 of n as x1 of n minus 1 as a special case, and y2 of n as x2 of n minus 1. Okay, so a1 into, instead of y1 of n, I'm going to write this thing, x1 of n minus 1 plus a2 into, instead of y2 of n, I'm going to write x2 of n minus 1. Okay, this is equation number 2. And what about equation number 1 and 2? Are they equal? Yes, they are equal. So it is clear that the system is linear. Okay, now we go to check the stability of the system y of n equal to x of n minus 1. So assume that the input, bibostability means input should be bounded. Assume input mod x of n is bounded. Therefore, mod y of n will be equal to mod of x of n minus 1. What is the nature of mod of x of n minus 1? Provided x of n is bounded, mod of x of n minus 1 also should be bounded, right? Because what is the difference between x of n and x of n minus 1? X of n minus 1 is just a 1 unit delayed version of x of n. That is not going to affect the stability or convergence, right? So since x of n is bounded, x of n minus 1 also should be bounded. Therefore, y of n is bounded. Therefore, the system is bibostable. System is bibostable. That's the final answer. Welcome to the next video of Pros and Experts. So the next question is, let f of t is equal to 2 times u of t minus u of t minus 2, and g of t is given by e raised to t into u of t minus u of t minus 2. Two questions. First one, sketch the functions f of t and g of t. Let us do that. Sketching f of t and g of t. So f of t, let me rewrite it, is 2 times something is in the bracket, which is u of t minus u of t minus 2. Okay, so you plot u of t minus u of t minus 2, then multiply it by 2. It's very simple. So what is u of t? this is u of t. Okay, it starts from 0, right? I must write it here, u of t. And what is u of t minus 2? I mean minus u of t minus 2. Here is a minus. You can see a minus here. Okay, so what is minus u of t minus 2? Again, it is step function starting from t equal to 2. Unit step function starting from t equal to 2, but it is negative, right? It's negative. U of t is positive, but this one is negative. And we have to find out u of t minus u of t minus 2. It's nothing but all portion except this, all portions in the shaded region will get cancelled, so only this portion remain. Okay, so I can plot f of t equal to 2 times u of t minus u of t minus 2 as this thing. So this is u of t minus u of t minus 2. This is a rectangular pulse or gate function, and since it is u of t minus u of t minus 2, the amplitude is 1. But in the question, you are asked to find out 2 times u of t minus u of t minus 2. So that makes the amplitude of this function as 2 times 2. Okay, so this is the answer to question number A. That is to plot 2 times u of t minus u of t minus 2. And question A has one more signal to plot, that is g of t, where g of t is given in the question as g of t is equal to u of t minus u of t minus 2. That should be a rectangular pulse, same as this thing, okay, same as this function with amplitude 1, okay, but that is multiplied by e raised to t. Okay, so you can imagine the signal. U of t minus u of t minus 2 will be having the same shape as this, but the amplitude will be 1. Okay, that is to be multiplied by e raised to t. What is e raised to t? It is an exponential signal. What kind of exponential signal? It is an increasing exponential signal. That's right, increasing exponential signal. So I can plot increasing exponential signal e raised to t. Okay, I'm going to plot e raised to t on this axis. But before plotting, let me ask you, what is the duration of e raised to t? Is it a right-sided signal, or is it a left-sided signal, or is it having both sides? Of course, the answer is e raised to t is a two-sided signal. It extends from minus infinity to plus infinity, and it is a growing exponential. So it will be coming like this. Okay, it starts from minus infinity and ends to plus infinity. Okay, and at t equal to 0, it crosses 1, right? Okay, now our aim is to sketch g of t, which is e raised to t, that is this signal, multiplied by u of t minus u of t minus 2 with amplitude 1. Okay, let me change the amplitude as 1. Okay, so what will be the answer? So you can clearly see that multiplying that gate function with our exponential function will result in a signal like this. Okay, all other portions less than 0 and greater than 2 in the time axis for this signal gets trimmed off, because you are multiplying it with a gate function, because in this gate function all the amplitude in this axis greater than 2 and less than 0 is 0. Okay, so this is the answer, ultimate answer to the question A. You have plotted 2 times of u of t minus u of t minus 2, and now e raised to t into u of t minus u of t minus 2. Now question number B. Question number B asks you to compute f of t star g of t, where star denotes convolution. So we have to convolve the signal f of t. Signal f of t was 2 times u of t minus u of t minus 2, and g of t. This is g of t, this signal. Okay, let us do that. So let us start with the convolution equation. F of t convolution g of t will be equal to integral minus infinity to infinity f of tau into g of t minus tau d tau. We all know this as per definition. It is a convolution integral equation. So what we have to do is you have to find out f of tau, right? We have f of tau here. This is f of tau. Then we have g of tau here. G of t can be converted as g of tau only by changing the index to tau. Here also index is tau. No other difference. Okay, so you have g of tau. Now we have to find out g of tau is actually e raised to tau into u of tau minus, no need to write u of tau minus u of tau minus 2 now. Why? Because the effect of u of tau minus u of t minus tau is implemented on the signal by trimming the signal in this portion and in this portion. Okay, so I think no need to write down this u of t minus u of t minus 2 any further. Okay, its effect is there in the signal by trimming it. Okay, so g of tau is e raised to tau. Okay, now according to the equation we have to take a g of t minus tau. So g of tau is this e raised to tau. So what is g of t minus tau? It becomes e raised to t minus tau. Okay, so let me tell you here, why should we take g of tau as e raised to tau? Why can't we take or interchange g of t and f of t? Because I'm saying this because the convolution operation is commutative, and we are going to shift to get g of t minus tau. We are going to reflect or fold this g of tau, then shift it to negative side, and then move it to the right side by incrementing t. Okay, but the signal is e raised to tau. It can be done, no problem, but a much simpler procedure will be obtained when you interchange f of t and g of t. Or if you calculate g of t convolution f of t instead of f of t convolution g of t, then integral minus infinity to infinity g of tau into f of t minus tau d tau. Now f of t minus tau, where the signal you have to fold, then shift, etc., is this signal. Okay, this is f of tau. This is a rectangular pulse. It can be simply shifted or folded, then shifted. The steps or procedure will be much simpler to understand. That's why I'm doing like this. Okay, so this is g of tau, and this is h of tau. Note that the amplitude of h of tau is 2, not 1. Okay, now you got to draw h of minus tau, and finally h of t minus tau for t initially a large negative value. Okay, this is h of t minus tau shifted by t units to the left because t is initially negative value. So since from h of minus tau you are finding h of t minus tau by shifting h of minus tau t units to the left, then I can write this leading edge as t. Okay, and this is minus 2 plus t. Okay, because we are adding actually here it was 0, we are adding 0 plus t, that is t. Okay, and here also we are adding minus 2 plus t, that is here. Okay, or for convenience I can write minus 2 plus t as t minus 2. Okay, and the amplitude is 2. Now what is the output at this condition? It should be 0. Okay, we are shifting h of t minus tau to a negative value to obtain an initial value. Here it is y of t equal to 0. Okay, and while we increment t slightly, this product remains 0 because multiplication with this signal and this signal at this position is 0. Okay, so up to what value of t while we increment does this product remain 0? Obviously the value is t up to 0. Okay, Okay, so y of t will be 0 until t is less than or equal to 0. Okay, so that must be our first condition of output, y of t equal to 0 for t less than or equal to 0. Now that we have obtained the first segment of output, then what is the next condition? Next condition is for t is greater than 0. That means, let me tell you, this leading edge comes closer to g of t, comes closer to g of tau, and the leading edge enters into g of tau, but the tail edge is still out of g of tau. Okay, only the leading edge is overlapping with g of tau, but not the trailing edge. Okay, let me draw that condition. Okay, I hope you can understand this condition. Now the leading edge is overlapping with the g of tau, but t minus 2 is not overlapping. So how can you write down that condition? T is greater than 0. Obviously, the leading edges inside g of tau means it is t is greater than 0. And the trailing edge is not overlapping, means t minus 2 is less than 0. So t minus 2 is less than 0. In other words, we can write it as 0 less than or equal to t less than 2. Okay, t minus 2 less than 0 means t less than 2. So t greater than 0 and t less than 2 means 0 less than or equal to t less than 2. Okay. Now we have to evaluate what is y of t in this specified condition. So y of t is equal to integral, actual equation is integral from minus infinity to plus infinity, and here we have to note whether we need to write minus infinity to plus infinity. No need, because the two signals g of tau and h of t minus tau overlap, or their product is non-zero only from 0 to t. Okay, 0 to t. So the integral limits is from 0 to t. Okay, integral 0 to t. Our equation is g of tau into h of t minus tau d tau. That is integral 0 to t. What is g of tau? G of tau is e raised to tau. Okay, so e raised to tau into, what is h of t minus tau? H of t minus tau is actually 2. Okay, its amplitude is 2, constant 2. So into 2 d tau. Okay, that is 2 into integral over 0 to t e raised to tau d tau will give you 2 times e raised to tau itself, and when you substitute the limit, you will get it as 2 into e raised to t minus 1. Okay, so y of t equal to 2 into e raised to t minus 1. What is the limit? Within 0 less than or equal to t less than 2. Okay, this is the second condition of our output. Alright, what is the next procedure? Next procedure is we still keep on increasing t so that this h of t minus tau moves rightwards. Okay, and what is the next significant output condition? This leading edge of h of t minus tau goes out of g of tau, but the trailing edge comes now inside g of tau. Okay, so how can you write it? Okay, this is such a case, right? The leading edge is out of g of tau now, but the trailing edge is inside g of tau. Okay, leading edge is t and the trailing edge is t minus 2. How can you write this condition mathematically? Now the leading edge t is greater than 2 and the trailing edge is now less than 2. Okay, the trailing edge is out of the g of tau, right? But the leading edge is out of the g of tau, and the trailing edge is inside g of tau, and that can be written as t greater than 2 and t less than 4, or 2 less than or equal to t less than 4. This is the new condition in which we are going to develop our output. Therefore, y of t is equal to, what is the integral limit? Instead of minus infinity to infinity, now the overlapping position is from t minus 2 to 2, right? After 2, here it is 0. Okay, so no need to integrate from up to t, right? So t minus 2 to 2 is the new integral limit. T minus 2 to 2 is the new integral limit. Now what is g of tau? G of tau is e raised to tau into h of t minus tau is constant 2. So 2 e raised to tau d tau. That is again 2 into e raised to tau is the integral from t minus 2 to 2, which can be written as e raised to 2 minus e raised to t minus 2. Okay, so this is the final output in the condition we have already derived 2 less than or equal to t less than 4. Okay, so I can consolidate all these output in all these conditions. Okay, before that, is there any further condition? If you still increment t, what happens? This t leading edge is already out of g of tau, and now if you increment t minus 2 further, this trailing edge also comes out of the g of tau, right? So in that condition I can write as t was already greater than 2. Now t minus 2 also is greater than 2. So that condition is t greater than 4 itself. T greater than 2 and t greater than 4 means it is t greater than 4 itself. Okay, and y of t, again blindly write it as 0 because no signals overlap in this condition, in this time duration. So y of t is 0. Now what I'm up to is to consolidate our output signal y of t. So y of t was initially 0. In one condition it was t less than or equal to 0. Then for the next condition it was 2 times e raised to t minus 1, I think. Yeah, that is for 0 less than or equal to t less than 2. And in the next interval it was 2 times e square minus e raised to t minus 2 for 2 less than or equal to t less than 4, and finally 0 for t greater than 4, greater than or equal to 4. This is the final output. The next question is, define the cross correlation function phi xy of tau for two signals x of t and y of t. Also, they are asking what is its connection with convolution. Okay, first let us define cross correlation. Cross correlation given by phi xy of tau is given by integral over minus infinity to plus infinity first signal x of t into a shifted version of the second signal. Okay, this is the definition for cross correlation phi xy of tau. I think you can analyze it very simply because if for tau equal to 0, phi xy of 0 will be equal to integral x of t into y of t dt. Okay, what does that indicate? That means we are multiplying signal x of t and y of t, or we are finding the similarity between signal x of t and y of t. Actually, before that, what is actually the concept of cross correlation? Correlation, whichever it is, autocorrelation or cross correlation. Correlation is the process of comparing the similarity between two signals. Okay, autocorrelation means you are comparing the similarity of a signal with a shifted version of the same signal itself. Okay, whereas in cross correlation, as we get an idea from the name itself, the cross correlation compares the similarity or checks the similarity between two different signals. Okay, one signal and a shifted version of another signal, right? From the equation definition, one signal and a time shifted version of another signal. Okay, so phi xy of 0 means we are just comparing the similarity between the two signals. No one is shifted. Okay, now what is phi xy of 1? It is integral x of t into y of t minus 1 d2. This imparts the very essential idea of cross correlation because phi xy of 1, what we obtain at 1 is we are taking x of t and 1 unit shifted version of the second signal y of t. Okay, so in case of phi x y of 2, we will be shifting y of t by 2 units, then comparing the similarity. Okay, in that way it goes. This is the idea of cross correlation. So I think you will never get confused between autocorrelation and cross correlation, and I think you will never forget the concept of correlation itself, because there is a funny method of explaining this correlation, like just comparing the image of a lady. Okay, image of the face of a lady before she puts some makeup and after she puts some makeup. Okay, image is a signal, right? So signal, the first image is the lady's face as such. The second image is her face after putting the makeup. What will be the cross correlation? According to this definition, if the two signals are very similar, the cross correlation value will be very high. All right. If the two signals are very dissimilar, the value will be less. Okay, and in this funny explanation, or in this funny example, what will be the value of cross correlation or correlation? Is that very high or is that very low? Oh dude, that's a very tough question, right? If your partner is with you, don't attempt to answer it. Okay, just free from there. Okay, so that is a tough question or not, I don't know. So I think this anyway, from this example you will be having mixed answers. I don't know what it is. Okay, fine. Anyway, ladies, please don't be mad at me. I'm saying this example not to forget this concept anymore. You study like this. Okay, you study concepts like this and you will never forget anything. Okay, so that's the first part of this question. One more part is there where we are asked to find out the connection of correlation with convolution. That's very simple. I can say that correlation phi xy of tau. Phi xy of tau means you are finding the cross correlation between signal x of t and y of t. Okay, so phi xy of t tau will be equal to x of t being convolved with, not with y of t, but y of minus t. This is the very important relation between cross correlation and convolution. Okay, so if you convolve x of t and a time folded version of y of t, what you will end up is with cross correlation. Okay, cool. Straight away to the next question. Consider an LTI system with impulse response h of n equal to u of n. Determine the stability and causality of the system. So you need to find out the stability and the causality. First, let us start with the stability. So you might be recollecting the criterion for stability of a system given the impulse response. If the impulse response is absolutely summable, then the system is stable. Okay, if impulse response is absolutely summable, then stable. So here in this question, sigma n equal to minus infinity to infinity mod h of n, we have to find out this thing. This is the condition whether this is the condition where we find whether this h of n is absolutely summable or not. So this becomes equal to sigma over n equal to minus infinity to plus infinity. H of n is given as u of n. Okay, so what could be the answer? Sigma n equal to minus infinity to infinity u of n can be written as sigma n equal to 0 to infinity u of n, because u of n is only a right-sided signal, so no need to sum up its 0 samples in the negative n axis. Okay, and what is the answer to this expression? You may have to expand the summation sigma. So put n equal to 0, u of 0 is 1, n equal to 1, u of 0 is again, u of 1 is 1, and all samples are 1 up to infinity. Okay, is it absolutely summable? No, its answer is tending to infinity, so it is not summable. Okay, so h of n is not absolutely summable that makes us say this system is unstable. Okay. All right, then we can check the causality, because that is the next condition to be asked. So causality. So when is a system causal? A system is causal if the impulse response is equal to 0 for n less than 0. A system is causal if its impulse response is strictly right-sided. It does not have any samples in the left side of the n-axis. Okay, that is the meaning h of n equal to 0 for n less than 0. So in the question, it is given h of n is equal to u of n. What is u of n? You can draw u of n very simply. It's a very common signal. This is u of n. Okay, h of n equal to u of n. From 0, 1, 2, 3, etc. There is obviously no any samples in the left side of the n-axis. No negative n samples are there. So straight away we can write that the system is definitely causal. As it is having no samples in the negative n-axis, the system is causal. And that's the explanation to that question. Let's see the next question. Find the convolution of a signal x of n equal to 1, minus 1, 1, minus 1 with itself. So the question is to find out y of n equal to x of n convolution x of n. Okay, you can do it either in a graphical method or in tabular column method. So it's only a 6 marks question. I think the questioner will be intending to do it in tabular method. So I am also going for tabular method. If you want, you can do it, verify the answer in graphical method also. Okay, so for the time being, I'm taking up with the tabular method, and in the question, no arrow marks are given. So let us take it default as this sample is at n equal to 0. Okay. Okay, so let's start doing this. So x of n, coefficients are 1, minus 1, 1, minus 1. Again, x of n, the coefficients are the sample values are again 1, minus 1, 1, minus 1. Now we make it columns. This is the tabular method. You tabulate this or make it as a tabular column. Okay, right. Now, what is the next step? We have to find the product in each cell. So this cell will be having value 1 into 1, which will give you 1 itself. Here it is minus 1, here 1, minus 1. Okay, here minus 1 multiplied by 1 will give you 1 here. No, minus 1 here, right? Here it will be minus 1 into minus 1 plus 1. Here it is minus 1 and here it is plus 1. 1, minus 1, 1, minus 1, minus 1, plus 1, minus 1, plus 1. Now what we do is you make it or arrange it diagonal wise. This one sample or values, these two values diagonally, here these three values diagonally. Now all these four values in a group, these three in the group, here, right? So all these values products are diagonally separated. Now you find out the sum in each diagonal, that will give the answer. Therefore y of n is equal to, here you have a 1 alone, so 1, comma, here you have a minus 1 and minus 1, which add up to minus 2. Then here 1 plus 1 plus 1 is 3. Here minus 4. Okay, here it is 3, then minus 2, and finally 1. So this is the answer. And where will be the sample at, which will be the sample at n equal to 0? It will be obviously this thing. Okay, because x of n starts at n equal to 0. Again, x of n also start at n equal to 0. So x of n convolution x of n should also start at n equal to 0. Okay, so this is the final answer.